Okay, we're ready to get rolling again with Tom Kelly. He's a program manager with FMCSA Advanced Technology Division, so I'm going to turn it to Tom. After this, we'll have our break, then we'll have our tour, so don't run off.
Thank you, and good afternoon, everybody. So I'm here to give you an update on some of the ADS research that that is underway at FMCSA, and then I'll also get into some of the other projects, and I'll end with the Level 8 update, the electronic inspection. So here's a quick snapshot of the industry. This is as of 2022, and as you can see, industry is growing. And again, the fatal motor vehicle crashes are going in the wrong direction. Hopefully that curve is going to move to towards the zero, but we're always, that's part of our mission zero, to reduce injuries and fatalities involving large trucks and buses. So as part of our ADS research, so FMCSA conducts its ADS and ADAS research under the automated CMV evaluation program. So, excuse me. So for ADS, the goal of this program is really to develop and execute a testing program that's utilizing research-enabled, Level 3 automation-capable tractor-trailers to conduct research into the development and deployment of automated CMVs. So this program helps FMCSA determine how best to enable the safe and timely deployment of these potentially life-saving technologies. So the program focus, the ACE program focus, is understanding how public entities will interact with ADS-equipped CMVs. So we test various use cases. We support industry standards and best practices development in our research. And our research also informs our regulatory activities and policy decisions with regard to ADS. So some examples of some relevant research underway. Development of on-road driving performance evaluation methods for ADS-equipped heavy-duty vehicles. So the team consists of a contractor, Virginia Tech Transportation Institute, and it's also partnering with several subcontractors, including a subject matter expert with prior professional truck driving institute experience. The FMCSA technology team also includes the VIII Center in collaboration with NHTSA. The goal of that project is to develop data collection and analysis tools, then collect and analyze field operational data using state-of-the-art technology to characterize driver behaviors as a benchmark for comparison to ADS-equipped medium and heavy-duty CMVs. So the status of right now, we're 2 years into a 4-year project. The second bullet, teleoperations, cybersecurity project. So the team consists of both VIII and the FMCSA Advanced Technology Division. The objectives of that project is to perform a cybersecurity assessment on the commercial motor vehicle teleoperation system using ISO SAE 21434 standards, which is regarding road vehicles and cybersecurity engineering. The other objective is to develop recommendations for cybersecurity considerations for the CMV teleoperation system based on the cybersecurity evaluation. So the outcomes will provide FMCSA with a better understanding of CMV teleoperation systems and their current cybersecurity landscape. And the results of the evaluation will help the development and deployment of CMV teleoperation systems. So that status is on schedule to deliver a final report for agency review in the first quarter of 2025. And the model operational safety plan for carriers operating ADS-equipped CMVs. So that team consists of VIII and our FMCSA Advanced Technology Division and other subject matter experts with operations and safety experience at medium and large motor carriers. So the goal of this project is to develop a model operational safety plan for motor carriers operating automated CMVs, and also to verify the plan by applying it to a hypothetical commercial motor vehicle fleet. So some of the outcomes and overview is the safety management system, and that system provides guidance for safe CMV operation. It also employs state-of-the-art functional safety standards and maps, and maps the automation system to the fleet operational environment. And the plan is modular and considers the system safety operational requirements determined by the technology developer. Fleet operators also can use the model operational plan to tailor a safety plan for their own operations. So the status of that activity, the final report is under review right now and will be published once that's completed. Other examples of some relevant research, the safety impacts of human ADS team driving applications. It's a 54-month research project led by VTTI, and that period of performance is from 2021 to 2026. And the objectives of that are to generate data to support policy decisions on hours of service relief, requests under 49 CFR 381, assess the safety benefits or disbenefits of human ADS teaming scenarios, and investigate existing and future human ADS integration models. Human ADS team issues such as fatigue, alertness, distraction, et cetera, and also fleet acceptance. So the approach of this activity or research project is to use simulator-based study augmented with vehicle demonstrations in a controlled environment. And we're using they've solicited real professional truck drivers in this capacity for this activity. And lastly, on this slide, no real update other than the NPRM for our motor carrier operation of automated driving system, ADS-equipped commercial motor vehicle, NPRM. So it's forecasted for December 2024. Take a snapshot of that QR code. It'll bring you to that page where that information resides. So on the this ACE inspections, demonstrations, and evaluations overview. So before I start with this, back, and I think Brett might have touched on it earlier. So we had a conversation with CVSA back, I would say 2018, 17, 18, about how do we inspect an automated vehicle in motion. How are we going to inspect these vehicles? So initially we put together a team with some contractor support from FMCSA to look at the various options on what we should consider. So there were 8 options that came out of that work group, and option 7 was the one that the work group recommended, and that was to have more of a terminal inspection or that enhanced pre-trip inspection that was mentioned earlier. Also, this project, we also wanted to understand how we can communicate with the vehicle in motion to the roadside. So this is where this project comes into play. So the overview really is to explore the processes and the communication methods that are needed to provide for the inspection activity on the roadside. And some of the operational test scenarios you see here, we had 6 scenarios, but we wanted to assess the ADS health while the vehicle is in motion. So how do we accomplish that? So that was one of the objectives. And we're also understanding that there's some predictive algorithms or predictive maintenance applications out there, and how can we learn from them? Because right now, like a fleet would be operating, and their home office has some indication as to the vehicle health, or that things are wearing down and it's due for service. So we wanted to learn about those applications and see how that would relate to this project. We talked about the enhanced pre-trip inspection communication. We wanted to see, okay, the enhanced pre-trip inspection happens, but how can we communicate those results to the roadside? And that's where we touched on in this project as well. And we also wanted to populate a roadside inspection application. We also wanted to understand if the ADS vehicle would respond to a pull-in or a bypass scenario, and the contractor sub to Prepass. I think Paul's in the room from Prepass. They were a subcontractor on this. Toxel was the contractor that had this contract. And then also we had some roadway scenarios, such as emergency lights to pull over and move over. So we wanted to see if the ADS vehicles could see the emergency vehicles roadside and react accordingly. So the high-level architecture is not shown here. That's fine. It did work when I had it on here earlier. There we go. So if those are interested in the high-level architecture, so the vehicle on the left, you see the little camera on the back end. We had a camera in the back, cameras in the front. We also equipped the tire pressure monitoring system sensors to be able to communicate some vehicle-type health. So other than just the camera and carrier data, we wanted to understand if we can communicate some maintenance kind of information, such as the tire pressure monitoring system. And also to communicate to enforcement and to the roadside. So what we did is, here's a sample of the safety data message set that was transferred as part of this activity. And you can see on the upper side, pre-trip inspector, name, inspector ID are the 2 of the elements, as well as some vehicle information. And we also, and it also talks about the date of the last enhanced pre-trip inspection. We want to be able to see if we can actually communicate, pertinent data regarding that. And then you see that the ADS health is also represented. And then I mentioned the tire pressure monitoring system. So this was a way for us to understand how we can communicate that type of data to the roadside as well. And all this was designed for this to render a decision whether to pull in or bypass. So we have, let me just click through these for the sake of time. So this is the communication path for the demonstration number 1. Again, does the ADS vehicle react when given a signal to bypass or to pull in? And then on the second demonstration, the pullover. So as Gary showed in his demonstration, he had a motor officer behind, and the vehicle reacted accordingly. So that we wanted to understand if indeed that could happen and what we can learn from that interaction. And then the last demonstration was the move over. So again, as they mentioned earlier, if there's an emergency vehicle on the side of the road, most states have a move over law. Would it react accordingly? So now I'm going to play a video. I think I have to hit the escape button. Well, I don't want that one. 1 second.
The development of automated driving systems, ADS, is both an enormous opportunity and a challenge to those who create the policy and inspection process that ensure the safety of both commercial motor vehicles, CMV, and those they share the road with. CMV safety is a primary concern of the Federal Motor Carrier Safety Administration, FMCSA. FMCSA's Advanced Technology Division has actively participated in and provided support to research initiatives that explore opportunities for using technology to improve CMV safety in support of the agency's mission of reducing truck and bus crashes on the nation's roadways. FMCSA is collaborating with the Federal Highway Administration, the VIII National Transportation Center, and the Maritime Administration to perform multimodal freight research for the safe integration of automated CMVs into the transportation network. As both of these efforts, FMCSA funded research through their Automated CMV Evaluation, or ACE program, to explore and demonstrate proof of concept applications, communication methods, and inspection technologies. These tools facilitate electronic safety inspection of ADS-equipped CMVs and safe interactions with law enforcement vehicles encountered on public roadways, at borders, and at other fixed enforcement locations. 3 driving scenarios were demonstrated in February of 2023 at the Virginia Department of Transportation's Smart Road Test Track facility in Blacksburg, Virginia. The project successfully demonstrated connected and automated vehicle technology for the interaction of automated CMVs at fixed safety inspection locations and on roadsides. Building upon existing open-source Karma software through agile software development and testing, the test event provided data, analysis, and results to inform national consensus-based best practices and standards. This scenario demonstrated the transfer of electronic inspection data. An ACE truck operated in automated mode approaches a simulated inspection facility such as a weigh station. FMCSA required the contracted technical team to have an existing weigh station electronic screening technology provider as a team member to demonstrate compatibility of the new ADS scenarios with existing electronic screening systems operating at hundreds of weigh stations in over 30 states. The technical team proposed the Pre-Pass Safety Alliance as their e-screening technology provider. In this scenario, as the ACE truck passes a roadside pre-pass transceiver, it receives a signal via an onboard radio frequency identification, or RFID, instructing it to either bypass or pull into the inspection station. The ACE truck then either maintains its present course in its current travel lane or exits the road to enter the inspection site. In either case, an electronic inspection safety data message is shared with the authorities directly and via FMCSA's SafeSpect system. SafeSpect is FMCSA's innovative inspection tool for collecting data related to the roadside inspection of a CMV. The motor carrier and its driver and vehicle information is shared via the SafeSpect online portal. In this scenario, the ACE truck identified a law enforcement vehicle with active emergency lights and completed a pull-over maneuver. The ACE truck, which is operated in automated mode at roadway speed, is approached from the rear by an SUV displaying flashing emergency lights on its rooftop light bar. Using its rear-facing camera, the ADS recognizes the presence of the approaching emergency vehicle. The ACE truck responds by automatically engaging its turn signal and then automatically changing lanes to the right shoulder of the road and stops. In this scenario, a move-over maneuver is demonstrated. Slow down, move-over laws are now enforced in all 50 states. The ACE truck, operating in automated mode at roadway speed, approaches an emergency vehicle with lights flashing to the right ahead. The ACE truck responds by slowing down, engaging its turn signal, and then changing lanes to give the emergency vehicle a wide clearance. After the emergency vehicle has passed, the ACE truck signals and returns to its original lane. As previously mentioned, the mission of the FMCSA is to reduce truck and bus-involved crashes, injuries, and fatalities. Automated vehicles have significant potential to reduce truck-involved crashes. FMCSA's Advanced Technology Division's ACE program, through demonstration projects like this, is supporting the development of national uniform safety inspection and law enforcement interaction procedures involving ADS-equipped CMVs for federal, state enforcement, and motor carrier industry decision makers. All related FMCSA ADS research efforts can be found on the FMCSA website on the Analysis, Research and Technology, and ACE program pages.
So I just want to talk briefly about this grant. This grant was one of 8 US DOT ADS sponsored grants, 2 of which that were given to FMCSA to manage. So this grant was awarded to the Virginia Tech Transportation Institute, and it was to develop a trucking fleet concept of operations for managing mixed fleets. So as you saw on the video that Brett stole from this grant. So you saw on this slide here, you know, the different ADS, the different deliverables that fed into the ConOps for the trucking fleet. So, and as you know, where is it? Inspections, ADS inspection procedures is one of the outcomes of this. So also the ConOps, the approach was to collect, demonstrate, and share. And you'll see on the, and I'm just going to page through this a little quicker. This is the website, and you can use that QR code to go to Virginia Tech's website where Brett stole my video. And other videos on that site also, there's another video on there. It's the Port of Oakland in California where we put a truck at inside the queue, and they turned on the automated vehicle function, and the vehicle made its way through the queue in the Port of Oakland, picked up a load, and then he did that for like I think a full week or 2. And so there's some of the things that they've learned during that scenario where, you know, people cut in, you know, people don't follow the rules. You know, the truck drivers in the port, they're looking to, you know, save some time and get ahead. So some of the things some of the human interventions that we would experience personally, how does the ADS react to that? And the ADS is kind of compliant. Yeah, go ahead if you want to go ahead in front of me, go ahead. So, and this is where I was going to show that video that Brett stole from me. That was part of that grant effort. So I'll save some time and move on. So now I'd just like to transition to talk about our research into an innovative inspection approach for vehicles with drivers in the driver's seat. And that's called our Level 8 Inspection Operational Test. So we're testing the feasibility, really testing the feasibility of whether or not this can happen. So the concept is to conduct electronically while the vehicle's in motion an inspection. So what information can be derived from the vehicle electronically, and can we capture that and create an inspection based on the CVSA Level 8 inspection definition that they established back in 2017, I believe, where they voted that in. So it's an actual level of inspection, but the technology wasn't available to get that moving. So now that things have modernized IT-wise, especially even at FMCSA, our own IT modernization with SafeSpect and other developments, we're in a better space where we can test this concept. So why are we interested? You know, because again, in cooperation with the state enforcement partners, we're looking at keeping the roadways safe by monitoring, you know, the compliance of vehicles. So we see here that we have data that shows the more inspections that are done, the out-of-service rate reduces. So if we collect more data on more carriers, will that still be true in a level 8 kind of concept? Also, the regulated motor carriers are increasing in population, and hence the national truck parking issue that has been mentioned several times today. So as the motor carriers continue to increase, more vehicles are on the road. But you see that our inspections have kind of decreased over the years. And it did dip during COVID, but we really haven't gotten back to the pre-COVID levels of the number of inspections. So before deciding whether to move forward with level 8 inspections, we need to be confident that we can electronically collect and process data that is reliable, accurate, and used in a way that benefits safety. So again, we're partnering with CVSA. CVSA is like the conduit between industry, enforcement, and the technology providers external to FMCSA. And then we are going to collect this data and evaluate and see what's the safety benefit of all of this information. So people are rushing to the end, but we're really here. We're at the very early stages of data collection. We're passively collecting information roadside. And we're also based on CVSA's level 8 definition. Right now, we're only collecting a small subset of that information. So that's represented on the bottom of the slide. And the operational test status is here. We have 7 test sites over 3 states. No, excuse me. We have 3 states, several test sites within each jurisdiction. And right now we have 6 carriers, and we've collected over 100,000 data transfers that potentially could be level 8 type inspections when all of that information is included. And some of our lessons learned is represented, is represented here. So in July, we had 4 participating carriers in 3 participating states. They had 30,000 events where they shared information with us, which is 380 times the number of the inspections that they generated normally. So you see on that bar chart on the right, level 1 through 3 inspections for those carriers in that same time frame, there were 79 inspections. At the same time, we generated over 30,000 inspection type events. So it's just the enormity of the information that we're collecting and that we need to understand before we move forward. Some lessons learned is really understanding the frequency. As represented here, we had 25% that had 1 data transfer within the month of July. And you can see down, 2% all the way down to where 2% had 31 data transfers. But largely, it's 1 or 2 per month, and then there's several, 2% of the, 6,000 had 31 or more data transfers in a given month. So some lessons learned so far it relates to data quality. So is what we are receiving what in fact was supposed to be sent? We're still working on that. We have some data quality issues. There was GPS location information that was missing from Mississippi that put those inspections in Texas, which isn't participating in the test right now. So we had to understand, okay, why is that happening? So we had this constant interaction with CVSA, the technology providers, and the states to try to understand what those data quality issues are. Right now we're trying to research some license plate state information in the data set, and we were able to resolve the timestamps. Originally, the timestamps, like every inspection, was at 5 a.m. We know that didn't happen. So why did that occur? So having that open collaboration with the technology providers help us resolve that issue. And so some of the next steps here, what we haven't incorporated into this test yet is the ELD data. So the carriers are going to be sent about, we have 6 carriers, major carriers. I don't think I have them listed here, and I don't want, if I recite them and I miss somebody, I didn't want to offend anybody. So we have 6 major carriers. I will say Schneider and JB Hunt were the 2 original carriers that participated. And so originally they were going to just flip a switch and then send us all the ELD information for all the drivers that they had. And yeah, we're not set up for that. You know, it's just think of 380 times what we are normally experiencing. So they are going to pick a handful of drivers per carrier to start with, and in the very near future start sending us some of the ELD information from those carriers. So what happens when the vehicle is driving down the road is going to hit a geo point, and it's going to trigger 2 events. One event is that inspection kind of information that we were getting now. The second event is telling it to upload the ELD output file to FMCSA. So when we get those 2 at FMCSA, we're going to marry the 2 together, create an inspection of its own. Right now they're level 4 inspections. It's a special study inspection, but we hope to build in a level 8 inspection within our SafeSpec suite of inspection tools. So as you can see here, we have data elements for initial testing, some that will be part of the message set when we integrate ELD, and then remaining data elements in the definition validating who's operating the vehicle. So that's kind of a hurdle that we're trying to understand, and we've even asked the industry to help us solve this problem. How can we ensure that the person in the seat is in fact the credentials being shared with us? We all know there's some issues out there, right? Falsifications and ghost drivers and things of that nature. Technology can only do what technology does, but it has to build in some assurances, such as who the driver is, making sure those credentials are in fact the driver. So there's more to come on this effort. It's a phased approach. We're in phase 1, just getting started, passive collection of data, and we're going to incrementally move forward by collecting more data, creating another inspection. So right now, when we get this complete data set, we're going to manually run credential checks, SID lists, registrations, carrier, IFTA, IRP, things like, we're going to be running those things manually. So as we progress into like a phase 2, we hope to automate those so that we're not extracting this information and running the credential checks. And at some point in time, as we progress through the different phases, there'll be, can we assess a violation with confidence, full confidence? Can we assess a violation based on the information we have? We also know EROD's data was never designed for this electronic inspection. It was designed for a human in the loop, where a human assesses the driver's hours of service, has a driver interview, collects some receipts or whatever, and validates what they're seeing. Right now, EROD's highlights potential violations, they're not actual violations. So we have some research projects underway to understand how we can use perhaps AI to look at understanding, if this, and this are present, the likelihood of a violation is whatever that percent is, closer to 100%. Not saying it's going to be 100%, but we're going to be analyzing that in a couple different scenarios, a couple of different research projects. So lastly, and at 3:01, despite the first scenario, the first speaker is using up the bulk of my time, I was able to get us back on schedule. So if you have any more questions on level 8, here's a QR code. You can look at our page and get some information. I know CVSA has a website on their homepage where they have level 8 inspections as well. But if you have any questions, you can email us at the team. This is the federal team, myself and my VIII partners. We all get that email if you send it to that address. So if anybody has any questions, I'll be glad to answer any questions that I can. Otherwise, we're up against a break. Questions?
I noticed in the pre-trip report you talked about the health of the ADS systems. Where do we stand with developing standards to define what constitutes the health of ADS system? And that it has successfully passed a pre-trip inspection and can be sent out on the road.
Just repeat the whole thing, Nick, if you would.
I noticed that on the pre-trip inspection, you talked about there was a field for an ADS health. Where do we stand with developing standards to determine what is the health of the ADS system, and how do you determine that it meets those standards and can be sent on the road?
I don't know if we are completely there. I do know that the industry is communicating. So the ADS health is probably different between Kodiak and Aurora. So it could be a developer by developer kind of issue, but it's something that we need to address and understand. And when we get a green light that says the ADS health is working, it's based on the criteria of Kodiak, Aurora, Torque, or others, Gaddick, or others. I don't think we have an industry standard yet. The Technology Maintenance Council at ATA, they developed this safety data message set that's kind of started this whole thing, but way back when we started having this conversation. Because early on, the industry, before our partners from California and Arizona became part of the team, the ADS developers came and said, oh, we got to stop for inspections? Yeah, you do. Or at least give us some confidence that, that the vehicle is safe, and maybe we don't want to look at it, but we're not going to give you carte blanche. I didn't say that we said states are saying that we're not going to give you carte blanche. So this evolved over time, having this collaboration with industry and enforcement and the regulators, so. Tom?
And Tom Keene, FMCSA. I was asked earlier, right before your presentation, is that whole list of pre-trip inspection elements public? Can somebody go find that if they wanted to, just to see what is checked, getting to Nick's question specifically?
Is that from our report, the TOXEL report? So once that gets published, we're in the final stages of publishing that report. It'll be available. That will be available.
Okay. And
That's separate than what the effort's going on at CVSA externally. We're not those data elements are perhaps different than what's represented on the screen earlier.
Right, but the CVSA list is public, right? All those elements that are checked?
I believe so. I've been getting
Okay,
some
yeah,
nods to that effect,
Yeah, I just wanted to confirm that. And also, there was a rumor stated earlier that Brett stole your video. I just want to, just kidding,
Yeah.
just kidding, thanks.
Yeah, that was part of a grant application of several deliverables, you know, and Brett liked his shiny truck, so he stole my video. It's all good. Any other questions? All right, well, we get snacks first then.